On October 2nd, something streaked across the Martian sky at 60 kilometers per second. Amateur astrophotographer Stephen Burns spotted it in NASA's raw Perseverance images, creating a time-lapse from 9 minutes of data. Other users analyzing the same images claimed to see multiple fast-moving anomalies in October 3rd data, plus a mysterious green flash nobody can explain. NASA had scheduled this observation deliberately. Multiple Mars orbiters were positioned to capture the closest images ever taken of an interstellar object. 3I Atlas, HiRISE Camera, Mars Express, and ExoMars Trace Gas Orbiter all pointed at 3I Atlas during its October 3rd flyby at 29 million kilometers. Then silence. No official images, no data release. Meanwhile, Harvard's Avi Loeb published something making the astronomical community uncomfortable. 3I Atlas might have been the source of the 1977 WOW signal. The chance of coincidence? 0.6%, but that's just the beginning. 3I Atlas breaks every rule for how comets behave. It produces industrial-grade nickel alloys in space. Its tail points the wrong direction. It glows green when it shouldn't. And it follows a trajectory so perfectly aligned with our planet that the odds are astronomical. Burns took 9 minutes of consecutive images and stacked them into animation. Something was cutting across the star field at 60 kilometers per second. For comparison, Earth orbits the Sun at 30 kilometers per second. Within hours, someone named Natchtaff made a startling claim. You can even see multiple comets. Not one object, multiple. Another user pointed out a green flash at the 3-second mark. Not a camera artifact or cosmic ray hit. This is diffused glow, localized but distinct. Green emission in comets typically comes from dicarbon, but spectroscopic analysis from the Very Large Telescope showed virtually no dicarbon. The object is chain depleted. It shouldn't be glowing green, yet photographs from ground-based telescopes clearly showed a green hue developing. When you stabilize the starfield, there appear to be additional points of light moving at different velocities. Could these be separate fragments accompanying 3I Atlas? Nobody can answer because NASA hasn't released the data. HiRISE can resolve features as small as 30 centimeters on Mars's surface. At 29 million kilometers, it should achieve resolution of about 30 kilometers per pixel. If 3I Atlas has a 5-kilometer nucleus, it should appear as a bright cluster of pixels. More importantly, HiRISE would distinguish between single compact nucleus and fragmented object. NASA's official statement: observations successful, data being processed, updates will follow. That was over 24 hours ago. Mars orbiters routinely make images public within days. ESA operates independently, yet their images haven't appeared either. The silence feels deliberate. The October 3rd flyby represented the closest any spacecraft has come to an active interstellar object. This was our chance to see its structure, determine if it's behaving like a normal comet or something else. Right now it's approaching the Sun. By late October, it will pass behind the Sun from our perspective, completely hidden. When it emerges in November or December, it will either confirm every natural explanation or have done something comets don't do. August 15, 1977. Ohio State University's Big Ear Radio Telescope was conducting routine sky survey. Astronomer Jerry Amon was reviewing printouts when he noticed something extraordinary. A signal had appeared, strong and narrowband, lasting exactly 72 seconds. The intensity was so far above background noise that Amon circled the sequence and wrote one word: wow. The signal came from Sagittarius, detected at 1420 MHz within protected radio astronomy band where no human transmissions are allowed. The bandwidth was narrow, less than 10 kHz, exactly what you'd expect from artificial transmitter. Big Ear never detected it again. For nearly 50 years, the WOW signal has remained one of astronomy's deepest mysteries. Until Avi Loeb calculated where 3I Atlas was on that date. In August 1977, 3I Atlas would have been approximately 600 astronomical units from Earth. The WOW signal originated from right ascension 19 hours 25 minutes, declination minus 27 degrees. Loeb calculated 3I Atlas's position. Right ascension 19 hours 21 minutes, declination minus 19 degrees, separated by 9 degrees total. The chance of random alignment, about 0.6%. If 3I Atlas transmitted the WOW signal, the transmitter would need to output between 0.5 gigawatt and 2 gigawatts. That's a typical nuclear power reactor's output. Not impossible for civilization capable of interstellar travel, but precisely the power budget that would make sense for deep space probe. The WOW signal showed frequency shift, blue shift, meaning the source was moving toward Earth. 3I Atlas moves toward the Sun at 60 kilometers per second. When you account for Earth's motion and geometry in August 1977, the relative velocity would produce blue shift. Loeb's calculated shift is close to observed. Broadcasting near hydrogen line makes sense for announcing presence. Hydrogen is most abundant element in the universe. Any civilization capable of radio technology would monitor it. The WOW signal lasted 72 seconds because of Big Ear's operation. The signal appeared in both feed horns sequentially, meaning the source was transmitting continuously. We don't have radio telescope data on 3I Atlas. No observatory has reported pointing radio dishes at this object. Loeb argues that needs to change immediately. The object is approaching perihelion, getting closer to the Sun, which means more energy available if there's any technological system involved. When comets approach the Sun, they shed material. Nickel and iron appear together in outgassing plumes, always together because they form together in stellar processes. The ratio varies slightly but follows predictable pattern. For every nickel atom, you expect about 10 iron atoms. Every icy body we've observed follows this rule, except 3I Atlas. The Very Large Telescope observed this object between August and September. In every observation window, nickel emission lines appeared bright and clear. Iron appeared only when the comet got closer than 2.64 astronomical units. Before that, nickel without iron. After, nickel with some iron, but in ratios completely unlike anything seen. The nickel-to-iron ratio measured orders of magnitude higher than natural processes would produce. 3I Atlas was releasing nickel gas at 5 grams per second. That's 430 kilograms per day. Over 3 tons per week from an object supposedly made primarily of water ice and rock. The surface temperature sits far too low to vaporize metallic grains containing nickel and iron. Something else is happening. Perhaps nickel exists as nickel tetracarbonyl, a volatile compound, but forming it requires specific chemistry. On Earth, we produce nickel tetracarbonyl industrially through the Mohn process to purify nickel. The chemical signature of 3I Atlas releasing nickel without iron mimics output of this industrial refining process. Loeb points out the observation matches what you'd expect from artificial nickel production. If it were technological object with nickel-based components or nickel-rich surface coating accumulated during interstellar travel, solar heating could ablate that material. The lack of iron would simply reflect composition of whatever is being eroded. Comet tails point away from the Sun. Photons transfer momentum outward, creating characteristic tail. On July 21st, Hubble captured highest resolution image of 3I Atlas. The image shows diffuse glow ahead of the object, pointing toward the Sun. Behind the object, where tail should be, nothing. The glow is an anti-tail. David Jewett analyzed surface brightness. The forward glow drops with steep slope, much steeper than typical comets. Steep fall-off suggests whatever is creating glow is concentrated near source and dissipates rapidly. Either material is extremely fine-grained and quickly pushed away, or there's active jetting from specific location, creating directed plume. What's harder to explain is absence of dust tail. If dust is being lifted in quantities sufficient to create visible forward glow, that dust should persist. We should see something, unless most of what we're seeing isn't dust but gas, which disperses and becomes transparent. The orientation of this jet points in direction of motion. The comet is traveling towards Sun and glow extends ahead in same direction. If you wanted to design braking system for interstellar object, releasing material forward would create thrust in opposite direction. 3I Atlas has shown no measurable non-gravitational acceleration, but that analysis has limits. Small accelerations would be lost in noise. If it were decelerating slowly through directed mass loss, we might not detect it yet. Between May and September, 227 observatories tracked 3I Atlas with over 4,000 position measurements. The upper limit on non-gravitational acceleration came out to less than 15 meters per day squared. This is astonishingly small for active comet visibly outgassing. James Webb detected carbon dioxide escaping at 150 kilograms per second. That's 13 tons per day. When you eject mass at high velocity, Conservation of momentum dictates remaining object experiences force. Gas has outflow velocity around 440 meters per second. If 3I Atlas showed negligible acceleration despite continuous mass loss, its nucleus must be massive enough that thrust becomes undetectable. The calculation yields minimum mass of 33 billion tons. 1I/Oumuamua had estimated mass between 10 million and 100 million tons. 2I/Borisov likely weighed few hundred million to few billion tons. 3I Atlas is at least 33 billion tons. This makes it 1,000 to million times more massive than previous interstellar visitors. Models predict small objects should vastly outnumber large ones. For every kilometer-scale object, there should be thousands 100 meters across. Objects this large should be extraordinarily rare. Models suggest we ought to detect between 10,000 and 100,000 smaller interstellar objects before encountering one this massive. We've detected 2. If 3I Atlas truly is 5+ kilometers across, and we're seeing it as only third interstellar object identified, either our models are catastrophically wrong, or we're exceptionally lucky, or 3I Atlas isn't random sample from expected population. On August 6, James Webb pointed its spectrograph at 3I Atlas. The spectroscopy revealed carbon dioxide, water, carbon monoxide, and carbonyl sulfide, all expected for active comet, but the ratios were profoundly wrong. The carbon dioxide to water ratio measured 8:1. In every other comet ever studied, water dominates. 3I Atlas inverts this completely. By mass fraction, the coma is roughly 87% carbon dioxide, only 4% water. This ratio sits 6 standard deviations above typical value. That's not outlier. That's different population entirely. Such high carbon dioxide content could indicate comet formed near carbon dioxide ice line, but even then you'd expect water present as significant component. This chemistry suggests formation conditions unlike anything in our solar system. Either comet comes from protoplanetary disk with radically different composition, or it underwent processes during journey that transformed makeup into something we've never encountered. Loeb calculated that 3I Atlas passed within 29 million kilometers of Mars, but minimum orbit intersection distance sits at just 2.7 million kilometers. That's remarkably close. Trajectory change of 10 to 15 kilometers per second applied during September would shrink closest approach to zero. If 3I Atlas isn't single object, if it's accompanied by smaller components, those components don't need to match main object's velocity. Mother ship releasing smaller probes can impart significant relative velocity. While main object passes Mars at 29 million kilometers, probe with right velocity vector could reach planet. Loeb considered what happens after perihelion. Object will be hidden from Earth observation from late October through most of November. It reaches perihelion October 29th. During closest approach, it will experience maximum solar heating, maximum stress on any structural components. If it's capable of maneuvering, perihelion offers strategic opportunity. Small velocity change at perihelion translates to large position changes months later. Loeb noted that with appropriate thrust, 3I Atlas could adjust path to intercept Earth. Velocity shift of 30 to 40 kilometers per second could bring it to Earth between late December and early January. Loeb created ranking system from 0 to 10 quantifying how likely object is to be artificial. 3I Atlas he currently ranks at 4. Not 0 because anomalies are too numerous. Not 10 because we lack definitive proof. That ranking could change dramatically based on what happens over next few weeks. Right now, 3I Atlas continues its journey, approaching the sun, heating up, becoming more active, potentially doing things we won't know about until weeks from now when it reappears and we see what changed. We've traced its path from outer reaches of space, calculated where it was when WOW signal reached Earth, measured impossible ratios in its chemistry, documented metals that shouldn't be there, mapped tail pointing wrong way. Maybe it's just a comet, an unusual one, but ultimately natural object following natural laws. The anomalies will resolve. The missing data will appear and clarify. Or maybe we're watching something that will rewrite every assumption about our place in cosmos. Either way, the next few weeks will tell us.